So we are, let's come to some trigonometric limits. Limits x tends to 0, sin x upon x equal to 1. Second we have is limit x tends to 0, tan x upon x equal to 1. Now when we are looking at these limits, it should be clear to us that whatever is the angle of sine, that same term should be there in the denominator for limit x tends to 0 equal to 1. Right? So we will check for the angle. And same is the case in tan. Whatever is the angle, that same term should be there in the denominator. And when it is limit here, it should be this same is there on left hand side here, or it can be a multiple of x. Okay, any multiple of x. If x is here should be x, and here it should be any multiple of x. Because if x tends to 0, then all its multiples tend to 0. Then only we have this limit equals to 1. And same is the case for tan. Whatever angle we are having with tan, that same thing should be there in the denominator, and multiple of that in the limit. Tends to 0, then the complete limit is equal to 1. And rest properties that we have studied earlier, like taking the scalar outside and all, that will be applied. Okay. Let's take one question based on this. We are taking question number 13 of your exercise. Limit x tends to 0, sin ax upon bx. Now, if we have to find out this limit, we know that whatever angle we have here, that same thing should be there in the denominator. Angle A we are having AX. That means denominator maybe it should be AX. So for making A, because A is not present here, A is there. So for getting A, we can multiply and divide by that constant. Right? Every time we can multiply or divide by same constant. So we are multiplying by A and dividing by. Right? Now, to get this limit, we should be writing it like this. Limit x tends to 0, and we are writing it in this form, sin ax upon ax. Because this is the product, so we can write it together. And this a upon b, it is a constant term, right? A upon b is a constant, and we know that any constant inside the limit by properties of limits, by algebra of limits, can be taken outside the, right? So we can write this a upon b. So our limit becomes limit x tends to 0 sin ax upon ax, and if we compare it with the property here, so whatever angle is there, that same thing should be there in the denominator, and multiple of that should be there in the limit. So this complete limit becomes equal to 1. So we can write it as a upon b into 1, and we get the result as a upon b. And whenever we are applying this, so we will write here that what we have applied. We have applied limit x tends to 0 sin x upon x equal to, right? We have to mention the property. Whatever property we have applied, like you mentioned the formula, like there is a formula here, so we have to mention that formula here, that this one we have. Yes, this we have applied. Okay. Let's take another question. Okay, we are taking next one, 14. Sin ax upon sin bx. Limit x tends to 0. Now we know that whenever fraction of two terms are there, or product of two terms are there, and limit, we are taking the limit. So we can separately take the limits by algebra. So we can product of two functions hai, so we can separately take their limits. We can also write it as limit x tends to 0 sin ax into limit x tends to 0 1 upon sin gx. Okay. Now for applying this property or applying this limit, we need ax in the denominator and Here we need bx in the denominator, yeah, in fraction of this. So we are multiplying by ax, and whatever term we multiply here, we have to divide by that also. Okay, let's write it here. And similarly here, we are multiplying by bx and dividing by bx. Now see, every time when I am multiplying here with bx with this sign, I am writing it before sign. So this I am writing because it should be very clear to you that whatever algebraic term we are writing with multiplication to a trigonometric term, that should always be written before that, so that we may not confuse with the angle and that algebraic term. Okay? If I write it here, यहाँ लिख दिया bx, so we may confuse that this is in the angle only. So whatever algebraic term we are writing in multiplication to trigonometric, always write it before that. Okay. Now all these are in multiplication. We have got sin ax upon ax. We have got sin bx upon bx, and this x can be cancelled out because all are in multiplication. So multiplication में variables हैं, they are x upon x, they can be cancelled out. What is left? This is a constant. We can take it outside the limit. Limit x tends to 0 sin ax upon bx into, then again this b is a constant, so 1 upon b we can take outside, limit x tends to 0 bx upon sin x. So again we have got this limit here. If we compare it with this, it is limit x tends to 0 sin x upon x, and this becomes 1, a into 1. Then multiplication 1 upon b, and this is 1 upon this limit. So 1 upon 1 is again 1, so this is again 1. And we get the result as a upon. Right? This is all these steps. You may skip any one of the steps here, like we are taking this product, you can do it directly also. But for your understanding, it should be clear that how are we taking this. Okay? Whatever is the angle, we have to multiply by that factor to get that in the denominator. And when we are multiplying, we have to divide by that. And whatever constant terms are there, we can take them outside the limit. Yes? Multiple, because if we are writing x tends to 0, it is ax, angle is ax here. No need to do the multiple here. If you can just mention it here that if x tends to 0, ax also tends to 0, right? So either you can write it like this or you can simply write it like this. Both are correct. Both are correct. Either you can write it like this, but you will mention it here. ठीक है कि if x tends to 0, ax also tends to 0. So if you just compare this with this term, you can write it like, and we can write it bx tends to 0. Also here mention bx tends to 0. Right. So if we compare it with our property, so now we have the same thing. So all the multiples, for that you are mentioning it separately. Yeah, note it down. Then we'll move to the next one. Now look at this. Done, Sarah? Now look at this here. We should be very careful to check whether the limit is extends to 0 or not. It should always be extends to 0, right? So here what we can do, because it is we are getting sine pi minus x upon pi minus x, but limit is not extends to 0, right? Limit always is like this. Whatever we are taking it is limit extends to 0 sin x upon x. Whatever angle we have, that same thing in the denominator, that same thing here tends to 0. But here it is x tends to pi. So we can do this question in two ways. One is what we can take, if we are taking, it is pi minus x here. So we can subtract pi from both the sides. One method that we can apply. Subtracting pi from both the sides in the limit. We can write it like this. X minus pi tends to pi minus pi. Same operation can be done in both sides of the limit. And this is sine pi minus x upon pi into pi minus x. What do we get? Limit x minus pi tends to 0. And if x minus pi tends to 0, so pi minus x also tends to 0. Because we are taking a negative sign common, minus 0 is nothing. So if x minus pi tends to 0, we can write in the next step that pi minus x also tends to 0. This 1 upon pi is a constant term, we can take it outside the limit. And we get sine pi minus x upon pi minus x. And in the next step, we can write it like this. Pi minus x tends to 0, sine pi minus x upon pi minus x. Now this is completely, if we compare it with our property, this is similar to that. Whatever angle we have, that same thing in the denominator, that same thing in the limit tends to 0. So this completely becomes 1 and we get the result as 1 upon 1. Okay, one thing. Secondly, how you can do it is, you can change the variable. I'm giving you those are methods. You can change the variable. One is this way that you can do, or you can also do it like this. Put pi minus x equal to, right? We are changing the variable. We can also do this question like this. Now, if we put pi minus x equal to t, what are we having here? X tends to pi. So if x tends to pi here, what will t tends to? If x tends to pi, if I put pi in place of x, what will be the value of t? 0, right? So we will just change the limit also. If we are changing the variable, that means it will be changed everywhere in the question, in the limit also. So pi minus x equal to t. So if x tends to pi, t tends to 0. We can write it like here, like this. Pi minus pi, which is ठीक है x tends to pi मतलब x की वैल्यू हमने यहाँ pi पुट करी so x की वैल्यू pi पुट करते ही we get the value of t as 0 that means if x tends to pi t tends to 0 so we can just change the variable in the question and we can write it as limit t tends to 0 sin t upon t and 1 upon pi is constant again we are getting this limit here और हमें पता है कि this limit is equal to 1. So we get 1. So both ways you can do whichever you find easy. Either you can change the limits like this by applying minus pi to both the sides or you can change the variable. And if you are changing the variable, you have to change it the limit also. सारे question में same variable होना चाहिए. ठीक है? जैसे ही हम यहाँ पे variable change करेंगे, so in the next step, we will change the limits. Here, so both ways can be done. Note it down. Then we come to the next question. Now let's come to question number 17. Done? Now this is the question. Limit x tends to 0. Cos 2x minus 1 upon cos x minus 1. Two most important formulas of trigonometry. Many times and many places they are to be applied, right? You have always to remember them. Two most important formulas of trigonometry. One is 1 minus cos 2 theta, which is 2 sine square theta. Another is 1 plus cos 2 theta, which is 2 cos square theta. Very important. Okay, 1 minus cos 2 theta minus है तो it is 2 sin square theta. 1 plus cos 2 theta, it is 2 cos square theta. Whatever angle is there on left side, 2 theta है तो right side में angle half हो गया theta. ठीक है. Similarly here, it is cos 2 theta minus 1. Let's take a minus sign common first of all. This is for your understanding. 1 minus cos x लिख सकते हैं. दोनों से minus sign common लिया and it cancels out. What do we get? 1 minus cos 2x. So we can apply 2 sin square x. Just put 2 sin square x. Angle half हो गया. 2x half तो x हो गया. Same formula. 1 minus cos x. अब angle क्या है? x या theta. तो angle will become. What will be the angle become? Half. Half मतलब कितना हो जाएगा x की जगह? x by 2, right? जितना भी angle है, it will be half of that. So angle will be 2 sin square x by 2. ठीक है? बहुत जगह यूज होते हैं ये दोनों फॉर्मूले. If it is a plus sign, तो 2 cos square theta. If it is a minus sign here, तो 2 sin. 2 can be cancelled out. Limit x tends to 0. Now we have learned the limit, that is limit x tends to 0 sin x upon x equal to 1. यहाँ पे पावर क्या है? 1 है. एक sin x है. ठीक है. यहाँ पे जब sin square x है, that means there are 2 sin x. Sin x into sin x, right? Similarly here, it is sin x by 2 into sin x by 2. Right? That means we have to divide by, to get this limit, we have to divide by x square. Okay? What does this mean? Sin square x means sin x into sin x. So once we need to divide by x here, and secondly we need to divide by x here. जितना भी पावर आ रहा है उतने ही x से डिवाइड करना पड़ेगा. Whatever is there in the angle. यहाँ पे जितनी भी पावर है उतने ही x by 2, उतने ही x by 2 से डिवाइड करना पड़ेगा. ठीक है. तो the power is 2, that means दो बार हमें x by 2 से, that means x square by 4 से we have to divide. Clear? So be very careful here whenever you are making this limit. If it is a cube, so we have to divide by x cube and multiply by x. If it is a cube here, so x cube by 8. So divide x cube by 8 से. So what do we have to do here? Limit x tends to 0 sin square x. Let's write it like this, into limit x tends to 0 1 upon sin square x by 2. So we need to divide by x square by 4, multiply by x square by 4. And similarly here, divide by x square, multiply by x square. Is this clear? Why have we done this? Dividing by x square, multiplying by x square, और यहाँ पे क्या चाहिए था हमें? ये था x by 2 into x by 2. That means x square by 4. So dividing by x square by 4, multiplying by x square. All the terms are in multiplication. We can take the constant term outside the limit and we can cancel out the variables. So this x square and this x square will cancel. Okay, constants outside. This is limit x tends to 0, sin x upon x whole square. This becomes 1. Let's see what is the constant. It is 1 upon 1 by 4. So 4 will be there. And limit x tends to 0, x square by 4 upon sine square x by 2. Again, this becomes 1 by applying the property. So we get the answer as 1 into 4 into 1, which is here. Any problem here in this question? Any problem? Done? Let's come to question number 18. Okay, we are taking 20th question. 18th is also similar as 20th only. Limit x tends to 0, sine ax plus bx upon ax plus sine. Yes, what can we do to simplify this? Who's going to tell? Yes, sir. Distribute करने के, okay? What thing this? The thing, sit down. The thing which is firstly to be checked in is that we need to put the limit in the form sin x upon x, right? Because we know that property, sin x upon x. बाकी जो single variable है, so that can be easily dealt with. Okay. So we need sin ax upon ax here, and we need sin bx upon bx here. So before separating the terms, it's easy for us, or it will be easy for us to multiply and divide by ax. We are dividing by ax, and if we divide by ax, we have to divide the complete term. Right? We cannot divide a single term because they are in addition. So we have to divide the complete term. And since we are dividing, so we have to multiply also. Because only dividing will change the question. Whenever we need to divide, whenever we are dividing by any term, we have to multiply. Let's come to the denominator. Here we need sin bx upon bx. So let's divide by bx. And again, we have to divide the complete term. So it is sin bx upon. And since we have divided, we have to multiply it. Okay? Now, these two variables will cancel out. Now we can separate this limit. This is a constant, we can take it outside, and limits we are separating. We can separate it in the numerator and denominator. We can separate it in the plus sign also. Okay? So let's separate it now. So we are taking constant term here, limit x tends to 0, and since x tends to 0, ax also tends to 0. Its multiple always tends to 0. We have sin ax upon x plus. Then what do we have? It is a is the constant term which is outside, and these variables cancel out. They are also constant. So limit of any constant term is always constant. So limit x tends to 0 b upon. And similarly look for the denominator. B is a constant term. These variables will cancel out. Limit a upon b x tends to 0 plus limit x tends to 0, and since it is bx, so we can write the limit in terms of bx. If x tends to 0, its each multiple tends to 0. So we can write dx tends to 0. Sin dx upon. This is 1. A is left. Here, this is b upon a. And limit of a constant term is always that constant. So what is left here? A plus a into b upon. Let's come to this part. Limit a upon b will be a upon b itself because it is constant. So b into a upon b plus. This term becomes 1 and we are having one more b outside. Plus. So let's cancel it out and it is a plus b upon a plus b, which is equal to. Okay. So wherever you see sin x, you just try to make sin x upon x. Okay. That's all for today. One question is left in this, that is question number 22. We'll be taking it tomorrow, and then we will be moving to left hand limits and right hand limits. Thank you. Have a nice day.